Once the different parts arrived in French Guiana, they were transported to the Launch Vehicle Integration Building, the MIC, where the first 3 stages were assembled horizontally, starting with the 4 boosters, which were strapped to the second stage, followed by integration of the third stage. Meanwhile, the 4 O3b satellites arrived at Cayenne's Félix Éboué Airport on the specially equipped Antonov plane and were then transported to the payload processing facility at the Guyana Space Center. Here, teams performed a series of tests to check the good health of the satellites in the utmost cleanliness. They were then sent for fueling operations before attaching the 4 of them using a special dispenser system. The dispenser and the satellites were then transferred to the O3b building, where they were integrated into the frigate upper stage. The whole thing was carefully hoisted and encapsulated inside the protective case of the fairing to form what's known as the upper composite. After a series of review meetings, the first 3 stages of Soyuz were then transferred horizontally to the pad on its launch table. The vehicle was then raised to a vertical position inside the mobile gantry, which protects it and provides feed lines until it's retracted 1 hour before launch. The upper composite, that's the fairing and the satellites, frigate and the dispenser inside, was then transported to the pad. There they were hoisted on top of the Soyuz and mated with the third stage that same day. The fluid and electrical connections were then activated along with the air conditioning inside the fairing. And I am now back in my commentary box upstairs behind the audience here in the Mission Control Center, and I'll be continuing the program from here. So we're coming up to a key milestone here. We have 2 automated sequences, as we said earlier, and the frigate upper stage entered the final phase of its automated sequence, that was about 5 minutes ago now. And the one for the main Soyuz vehicle is now entering its final phase. That's the last 5 minutes and 9 seconds. It's called Kluch na start, Kluch meaning key. And the computers are managing an impressive list of operations. The teams are monitoring this in the launch control room. That's about a kilometre from the pad. 3 teams here, one responsible for the ground operations on the Russian side as well, and the next team is responsible for the flight readiness of the vehicle. That's led by the Arianespace production manager. And on the Russian side we have Mr. Kapitonov. Another team is the CVI, Immediate Visual Control. During the flight, the launcher sends information to the ground to tell us how the flight is progressing in real time. And this team receives that information. They then pass it to the Range Operations Manager, who sits here in Mission Control. And he then announces the confirmations of the major events to everybody who's listening across the range. That includes in the downrange stations. That white smoke you can see is liquid oxygen evaporating. We have to keep it at very low temperatures. Thales Alenia Space has built all 3 satellites. This is the Thales teams. That was Andres Dilvaris, the satellite mission director. And he manages the relationship between Thales and Arianespace for O3b. Everyone busy there. They're in the fishbowl, as we call it, and you can see those status panels up there that Claude talked to us about just a short while ago. So, if you can see just at the bottom of the image there, a big grey mast. There it is, that big grey mast attached to the vehicle. It's called the KZM, an umbilical mast, and inside it it's carrying all the umbilical lines, we call them, to the satellites, keeping us in touch with the satellites for the teams on the ground. You'll see those lines disconnecting just before launch.
Largage des ombilicaux, ciao.
There we go. The range operations manager is telling us that the lines are being disconnected. You'll see the mast pulling away before launch. We can't actually see those lines because they're inside the mast. And the lower stage mast is below that. It's called the VKM and we can't actually see it at the moment, but we'll see that retract shortly before launch as well. A little word about the ignition sequence. On Soyuz there's a system for checking the health of the engines before it leaves the pad. The engines on the 4 boosters and the core stage are all ignited 20 seconds before liftoff, and then thrust is gradually increased. This is to check that the engines are all working fine. Don't forget that Soyuz can carry people into space, so we absolutely have to be certain. Then the engines are throttled up to full thrust, and at that point the vehicle leaves the pad. Couple of things to watch out for just as we come now in these final seconds to launch. 35 seconds before launch you'll see that big KZM mast pulling away. Then minus 18, well minus 20 we'll see ignition of the engines.
À tous de DDO, attention pour moins 1 minute.
He's coming up for the 1 minute mark.
Top, H0 moins 1 minute.
We are 1 minute to launch. We're orbiting the third batch of satellites in the O3b constellation, which Thales Alenia Space built for O3b
Largage du
networks.
Macazedem.
And we're flying on board the 10th Soyuz to launch from the Guyana Space Center. We're switching to onboard power now, so let's sit back and watch. Our best wishes to all the teams.
À tous de DDO, attention pour le début de la séquence d'allumage lanceur. Top. Largage du VKM. Allumage triétage. À tous de DDO. Attention pour le décompte final. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Top. Et décollage. Les paramètres de commande sont nominaux. La propulsion du premier étage est nominale.
Superb images as always. Soyuz blasting off into the sky above French Guyana. Heading out across the Atlantic, hauling itself against the pull of the Earth's gravity, all 300.
Est nominale.
Everything's going according to plan, he says. All 310 tons. We're burning 5 engines, 1 on the core stage, 4 on the boosters. There it is, coming out from behind the clouds.
Tous les paramètres à bord sont normaux, le vol est nominal.
Boosters are doing all the work right now. They're delivering 80% of our thrust. In fact, the total thrust is 336 tons. That is the equivalent of 3 Airbus 380s, you know, the great big planes, the double-deckers, or 7,500 family-sized cars. We're heading out east at the moment over the Atlantic Ocean. We're going to be travelling along the equator. Of course, this is the most efficient way to get to our required orbit, because we're travelling in the same direction as the rotation of the Earth, so we're saving on propellant.
Tous les paramètres à bord sont normaux.
And you can see the boosters falling away back to Earth. There they go. Can you see those 4 cylinders twisting and turning? It's all
B, V, GD.
very carefully planned. So it's great to have been able to see that with the naked eye. The reason why we have now lost the boosters is because we don't need them anymore. They've burnt out their propellant, and of course the lighter we are, the faster we go, so we're shedding weight all the way through the launch. And we're now burning the main core stage, or the second stage, often known here as the Block A. A word about confirmations of major events in the flight. We are seeing key moments happening at the right time, but we get the actual confirmations of those milestones, sometimes slightly later, and that's perfectly normal.
Tous les paramètres à bord sont normaux.
That's because it takes a little time for the information to get from the launcher to the range operations manager here at the Guyana Space Center, because the information goes via Moscow. That's where it's validated before coming to the Launch Control Center here at the CSG. Remember, we saw the teams there in the CVI. They then pass the information to the Range Operations Manager. Tonight that's Joel Igalji, and he calls out the confirmations only once he's got them. You can see on the top right-hand side of the screen, we call it the curve, the trajectory. The white dot is the actual position of the launcher. And there you can see that's the fairing, the tip, the nose of the vehicle. It has several jobs. Notably, it's protecting the satellites from the rigours of the launch. You can imagine how loud it is. Those acoustic vibrations. And also, it's protecting the satellites from friction because it's travelling through the dense part of the atmosphere. So it's very hot. But no longer. We are now, if you look at our altitude on the bottom left-hand side of the screen, 127 kilometres above the Earth, we've come out of the thickest part of the atmosphere. And so there's no friction anymore. We've been able to lose that fairing. It falls back down, and we can see our four babies, the O3b satellites, for the first time. Lovingly built by the men and women at Thales Alenia Space, who are experts in this kind of thing. The blue rectangles you can see on the right-hand side of the screen there, if you can just about make them out, those are the solar panels. The satellites are folded up during launch, and they'll be deploying those solar panels at separation. So we now have ignition of the third stage, and the second stage has fallen away back to Earth. And these are superb images from a previous launch. We had some onboard cameras. That's the real deal there, and you can see the planet, our planet below us.
Extinction du bloc A et séparation. Tous les paramètres à bord sont normaux.
He's telling us that everything on board is normal. We're looking at
la section arrière, stabilisation du lanceur confirmée.
We're looking at computer-generated images. They're showing us what the experts have calculated is actually happening to the launcher and the satellites in space. There they are, those images there on the middle part of the right-hand side of the screen. Basically, the teams plan a very precise schedule of events based on extremely accurate predictions, and then they put all that information into the computer, and these images are a simulation of those predictions. So every movement and every position that you see is based on exactly what has been planned for the flight. That thin blue line there is the Earth's atmosphere. Not very thick, is it? It's only taken us, took us about 4 minutes to get out of the Earth's atmosphere. Makes you realise that we really do need to look after it. Today is the 11th launch this year from the CSG. Arianespace can perform 2 launches in less than 2 weeks. Here's the news. In December, Arianespace orbited DirecTV-14 and GSAT-16 for long-term partners DirecTV and India's ISRO Space Agency, extending Ariane 5's string of successes to 63 in a row. Ministers from ESA's member states have given the green light to start developing the new launcher Ariane 6 with an expected maiden flight in 2020 and an enhanced version of Vega planned from 2018. Ariane 6 will be designed to benefit from economies of scale, in particular in manufacturing the solid rocket boosters used on the 2 versions of the launcher, as well as on the first stage of Vega C. Arianespace welcomed the European countries' collective commitment to the new vehicles as a decisive step in maintaining Europe's competitive edge in a worldwide marketplace which is constantly changing, thanks in part to the growing popularity of electric propulsion on satellites. Meanwhile, here at the CSG, teams are preparing upcoming launches. ESA's IXV is due to fly on Vega on the 11th of Feb 2015. It's to test atmospheric re-entry on future reusable launch vehicles. Teams have been working since November to assemble the next Ariane 5, ready to launch Thor 7 and Seacral 2 in March. And interestingly, with these 11 launches in 2014, Arianespace has broken its record of total satellite mass launched in a year. If you add up all the satellites lofted by all three versions in 2014, it makes a total mass of 78.3 tons. That's a lot of satellite. So our flight path takes us east across the Atlantic along the equator, and we're tracking the launcher using the ground stations. It's called telemetry. What happens is Soyuz sends data to the stations as it flies over, and this tells us how the flight is progressing in real time. Picked up the signal at the ground station in Natal. The next tracking station is in the middle of the Atlantic, Ascension Island. The next one after that is Libreville, which is on the west coast of Africa, and then we'll fly across Africa, pick up the signal at Malindi in Kenya, and then across the Pacific, and then the guys and girls at the tracking station at South Point in Hawaii will pick us up for separation. So we have the scheduled time here for the third stage to shut down its engine, and off it goes. We're shedding weight at each stage. As soon as everything has burnt its fuel, we get rid of it. Of course, it's a basic law of physics. The lighter we are, the faster we go. So we're starting the next phase of our journey, and Frigate has taken the wheel. Frigate is that gold structure, the cylindrical structure to the sort of bottom left. You can see the satellites are attached with the central dispenser. We have the confirmation there of the separation. Frigate is the gold structure, and it has 6 spherical tanks. They're organized in a circle. 4 of those are for propellant, and 2 of those are for avionics. Avionics is what you would normally find in the cockpit of a plane, the flight control systems, the navigation, that sort of thing. And they're attached using that specially designed dispenser or adapter. And Frigate's getting ready to switch on its engine.
Activation du contrôle d'attitude du frégate.
It's called a pre-burn phase. It gives a quick burst of acceleration. There we go, and it has switched its engine on. Frigate's job is to deliver our satellites to their drop-off point in space, and it's going to take a couple of hours to get there. During that time we have 3 propulsion phases. We have the first 2 burns. This is the first one, and those will take us to our transfer orbit, and then there's a coast phase. That's going to last an hour and 21 minutes. And then we have the 3rd burn. That takes us to our separation orbit, and that's where we'll be releasing the satellites. They'll be heading off on their own journey thereafter. It's quite interesting actually, because Frigate was originally designed as an interplanetary probe in its own right. And we have a new filling hall here under construction at the Soyuz launch complex.
As the pace of the launches for Soyuz, Ariane and Vega was being stepped up, we thought we had to improve our satellite fueling capacity. Frigate, the upper stage of Soyuz, is currently being filled in one of these halls. So we chose to have this new building dedicated to the filling of the frigate stage in order to make these satellite filling holes fully available and thus improve the launch manifestos of Ariane, Soyuz and Vega. With this new building, we shall be able to speed up the filling of the frigate stage. Filling time will thus be cut by about 1/3. We shall also cater for the filling of other satellites, if required, with just a few adaptations needed. The detailed studies started exactly a year ago in December 2013, so you see here what the building looks like already. Great progress has been made and we're on track to start operating it in June 2015, in 6 months from now. It's a really tight schedule, of course, but all this was made possible through the dedication of all the teams involved in this project, in particular contractors based in French Guiana, who helped us meet the deadlines of this extremely challenging schedule. So see you mid-2015 for the commissioning of this new building that will significantly improve the tempo of Ariane, Soyuz and Vega launches.
So all good there. Lots going on here at the base. So take a look at the bottom of your screen. Altitude bottom left, we are flying 190 kilometers above the Earth. The distance in the middle is the distance from the launch pad. So if you were to draw a line across the planet, that's the distance along the ground, 3,500 kilometers. And our speed on the bottom right hand side, we are flying at, well, over 7 kilometers per second, ladies and gentlemen, 7 kilometers per second. That's pretty fast. In the early phase of the launch, we were using all our power to get away from the Earth. Now we're using it to go faster so that we can climb higher into space later in the flight. We're going to be needing to get to just under 8,000 kilometers in order to start separating our satellites and releasing them. So frigate is getting ready to cut off its engine here. It lifts its foot off the throttle rather gently just to make sure everything stays nice and steady. And it's the onboard computer that sends the command to do that. The scheduled time of that cut-off is now. So we're entering the ballistic phase. This is going to last us just under 8.5 minutes. And ballistic means that we're travelling without propulsion. We're travelling high enough and we're travelling fast enough to cruise without the engine. And that's to optimize the conditions of the flight and also to save on propellant. O3b is a pioneering project, that's for sure. Its initial aim was to provide a high-speed, affordable internet from space to the other 3 billion people who don't have it. And of course now it's proving popular with other customers too, like cruise ships and the energy sector, to name but a few. As we said earlier, they switched on full services in September and it's exceeding expectations.